All right, so this is the second video. I had to do two videos because they won't accommodate as wordy as I am in one video. So the second video continues with the figures PowerPoint that you have in Module 9. And in this video, we're going to talk about charts or figures showing two variables. So the first figure I have here is a figure that shows a score of some point of some kind on the vertical axis. This vertical axis is called the ordinate, and the horizontal axis is called the abscissa. So an old friend I had, an old mentor, told me that she remembered ordinate because your mouth makes a up and down ordinate that goes vertically, and if you say abscissa, you're sort of smiling, so that's kind of horizontal. Anyway, so so on this graph, we're just showing two groups, the control group and the treatment group. And this graph actually shows the scores of all the subjects in a control group and all the subjects in the treatment group. So this subject very much at the top here has probably got about a 96. The one at the very bottom has probably got about an 11 in this group, and the one at the bottom of this group has a 30, and the top has a 70. One of the things you can notice if you do these kinds of graphs is how the treatment group is much more spread out in this graph, has much higher variability than the control group. And this treatment group will have a higher standard deviation than the control group. Okay, so this is just showing two groups. So to answer the question, is there a difference between groups, we use a statistic called the t-test. And I always remember the t-test as T for 2. So T is two groups. Two groups are compared on a continuous variable. And the means and the standard deviations of each group are used, and the calculations produce a t-value. And t-values are distributed on a t-distribution, which is like a normal distribution but slightly different. But it's the sampling distribution that we have talked about. But anyway, so here is an illustration. Again, we're showing just two groups, control group and the treatment group, on the abscissa. And this is, again, some kind of test score on the ordinate. So up here I've put the various data that are important. So the mean of the control group is 50.9, and the mean of the treatment group is 51.6. So there's a 0.7 point difference between them. And as you can see, the p-value of that difference is 0.93, so it's non-significant. Okay. Now, we also have the control standard deviation is here, and the treatment standard deviation is here. And then we have the control standard error and the treatment standard error. Remember, the standard error is based on the number of subjects in the study. And so the standard error for the treatment group is a little bit larger. And then this is the 95% confidence interval. This means plus or minus 12.87, which is, you can tell that from here. So these vertical bars, are considered the error bars, and the little horizontal cross hatches is where the means are. So this is the mean of the control group, the 95% confidence interval of the control group, and the mean of the treatment group, and the 95% confidence interval of the treatment group. As you can see, the confidence interval for the treatment group, you can see it is bigger here, and of course it's also bigger up here, 12.87 plus or minus. So this goes about 13 points above the mean of 51 and about 13 points below the mean of 51. Okay, now what the other thing that you should know is that not all of these vertical lines on a graph are necessarily 95% confidence intervals. Sometimes people put the standard deviation as that line, sometimes other things. So, but they're supposed to tell you what line they're using. So that's why I have this. The error bars are 95% confidence intervals. That's what that means. So they're supposed to tell you what they mean. Okay, so this is a comparison between groups, and the t-test is non-significant, and it's pretty obvious that it is because they're pretty much similar. Okay, now we have another t-test. I kept the control mean and all that data as the same, and the treatment mean here is what changed. So the treatment mean here is now 37.9. The treatment standard deviation is 11.93, and so forth. The confidence interval is smaller than the previous confidence interval, 7.39, and this is significant, p.04. So the mean difference here is a minus 13. Now, when you find out what the mean difference is, whether it is a plus or minus is sort of arbitrary. It depends on whether the investigators subtracted the treatment mean from the control mean or the control mean from the treatment mean. There's no standard way of doing it. So in the text, the investigator has to tell you which one is higher. And you can also look at it by comparing the means. And so you can see that the mean of the control group is higher than the treatment group in this example. Again, the error bars are 95% confidence intervals, and the crosshatch, the horizontal bars are the means. Okay, so here's another set of data. Again, I kept the control data the same, but this data has even a bigger difference between the means of minus 14.1, but the p-value is not significant. It's not less than 0.05. And what this is illustrating is has to do with the standard deviation. The standard deviation of this group is a lot larger than the standard deviation of the groups we looked at before. So the standard deviation here is 20.38, and the treatment standard error is 6.44. And so, so you have a wider standard deviation for this than you had in the previous one. So here is an illustration. You can see that the control groups here are the same, but the treatment groups are somewhat different in that this treatment group, where the p was significant, has a tighter confidence interval, and this one has a broader confidence interval, and that's the standard deviation that we're talking about. That's the variability that we're talking about when you have heterogeneous groups, more heterogeneous. So this group is more heterogeneous than this one, and it's harder to find significant results.